What if I told you the moon isn't there when you're not looking at it? Sounds mad, doesn't it? But hang on, that's not me being weird. That's literally what 8 Nobel Prize winning experiments have proven. Reality, the actual physical world you're sitting in right now, doesn't behave like a thing until something looks at it. And I know what you're thinking, mate, that's philosophy, not physics. Nah. Stockholm has handed out gold medals, 8 of them, to scientists who showed in the lab with hard data that the universe peeks back at you. By the end of this video, you'll understand why your morning coffee, your phone screen, even the air in your lungs is doing a sneaky little quantum dance every time you blink. And experiment number 6 on this list, it won a Nobel in 2022. It didn't just bend reality, it broke it. Stick with me. G'day, I'm your host at Curious Physics AU, and today we're walking through the 8 experiments that turned physics on its head, one by one, like dominoes falling across 100 years of science. Number 1, 1905. A young patent clerk in Switzerland writes a paper that nobody really wants to publish. His name? Albert Einstein. The experiment? The photoelectric effect. Here's the deal. If you shine light on a metal plate, electrons pop off it. Simple. But the weird bit is, the energy of those electrons doesn't depend on how bright the light is. It depends on the colour. Red light, no matter how blinding, won't kick electrons out of certain metals. But a tiny flash of blue? Boom. Electrons everywhere. That makes zero sense if light is a wave. Waves get stronger when you crank them up, like turning a speaker louder at a Bondi house party. But Einstein said, nope. Light comes in little packets, particles, photons. And the moment you measure them, they act like tiny billiard balls. That's Nobel Prize number 1, awarded in 1921, and it kicked off the whole quantum revolution. But here's the twist. Light is also a wave. So which one is it? Hold that thought. Number 2, 1923. Arthur Compton in America fires X-rays at a chunk of carbon. He watches what bounces back, and he notices something strange. The X-rays come back with less energy, like they've been in a fight. Compton works out the maths and realizes the X-rays are colliding with electrons, exactly the way 2 billiard balls would collide on a Sydney pub pool table. Photons have momentum. They're particles. He gets the Nobel in 1927. So now we've got 2 experiments saying light is a particle. And yet, just a few years later, we get number 3, and everything goes pear-shaped. 1927 again. 2 American physicists, Davison and Germer, are firing electrons, tiny chunks of matter, at a nickel crystal. They expect the electrons to behave like little bullets, scattering randomly. Instead, the electrons form a pattern of bright and dark stripes, the exact pattern you'd see if you fired a wave at the crystal. Electrons, solid bits of matter, are also waves. Davison shares the Nobel in 1937, and now we're in real trouble. Because here's the question that haunts every physicist for the next century. If matter is both a wave and a particle, what decides which one it is? The answer, terrifyingly, is observation, whatever's watching it. Now, before we go further, let me ask you something. Have you ever caught yourself in a mirror and instinctively fixed your hair? Of course you have. We all do it. The act of looking changes the thing being looked at least in your bathroom. In quantum mechanics, this isn't a metaphor, it's the law. Number 4, the Stern-Gerlach experiment, 1922. Otto Stern shoots silver atoms through a magnetic field. Classical physics says the atoms should spread out in a smooth, continuous pattern, like spray from a garden hose in your backyard on a summer arvo. But they don't. They split into 2 perfect, distinct dots, up or down. Nothing in between. The atoms didn't have a definite spin until they hit the detector. The measurement created the result. Stern wins the Nobel in 1943. And right here, this is where it stops being weird and starts being terrifying. Because now physicists are realizing that particles don't have properties until you check. They exist in a fuzzy cloud of possibilities, and the act of looking, literally looking, forces the universe to pick one. Imagine flipping a coin in the air. Now imagine the coin doesn't decide whether it's heads or tails until you catch it and open your hand. That's not a thought experiment. That's nature. Quick reset. Take a sip of water. Stretch your shoulders. Because what's coming next is the part of physics that even Einstein refused to accept. He famously said, "God does not play dice." Spoiler, he was wrong. Number 5. The Lamb shift. 1947. Willis Lamb, working in the United States, looks at the hydrogen atom, the simplest atom in the universe, just one proton and one electron. And he notices something that shouldn't be there. The energy levels are slightly off. Not by much, but enough. Where's that extra wiggle coming from? Empty space itself. The vacuum, it turns out, is not empty. It's bubbling with virtual particles popping in and out of existence faster than you can blink. And those particles are pushing on the electron, ever so gently. Lamb wins the Nobel in 1955. Think about that for a second. Right now, between your thumb and your phone, in the gap that looks empty, there are particles being born and dying trillions of times per second. Reality is humming. Number 6. This is the big one. 2022. 3 physicists, Alain Aspect, John Clauser, and Anton Zeilinger, share the Nobel Prize for an experiment that proved entanglement is real. Here's the setup. You take 2 particles, link them quantum mechanically, and then send them to opposite ends of, say, the Sydney Harbour Bridge, or opposite ends of the galaxy, doesn't matter. When you measure one, the other one instantly takes on the matching state, faster than light. No signal travels between them, they just know. Einstein hated this. He called it spooky action at a distance and spent the rest of his life trying to disprove it. He failed. The 2022 Nobel was the final nail in the coffin. The experiments showed with mathematical certainty that the universe is not local. The 2 particles are connected through something deeper than space itself. And here's the kicker. Until you measure one, neither particle has a definite state. The act of looking at one of them creates the reality of both, across any distance, instantly. Now, I know this sounds insane, but this isn't speculation. This is the technology behind quantum computing, behind quantum encryption, that the Australian government is right now investing millions into through institutions like the University of Sydney and UNSW. This is real, mate. This is happening in labs about an hour from where some of you are watching this video. Number 7, 2012. Serge Haroche in France and David Wineland in Colorado share the Nobel for something almost magical. They figured out how to watch a single quantum particle without destroying it. Normally, in quantum mechanics, the moment you measure something, you wreck it. It's like trying to weigh a grain of sand by punching it. But Haroche and Wineland built traps, incredibly delicate setups, that let them peek at individual atoms and photons gently. They watched, in real time, particles flickering between states, quantum jumps, live. It was like watching the universe render itself one frame at a time. And what they confirmed is wild. The act of measurement isn't just disturbing the system, it's choosing the outcome. The universe is genuinely undecided until you ask. Number 8, the most recent, 2023. Pierre Agostini, Ferenc Krauss, and Anne Lewillier win the Nobel for attosecond physics. An attosecond is a billionth of a second. It's to 1 second what 1 second is to the age of the universe. Using laser pulses that fast, they actually photographed electrons moving inside atoms. We have, sitting in labs right now, footage of the smallest building blocks of matter dancing around. And the data confirms it again. Electrons don't have definite positions. They exist as probability clouds. The camera doesn't capture where they are, it forces them to be somewhere. 8 experiments, 8 Nobel Prizes, 1 conclusion. Reality is not a thing, it's a relationship. The universe doesn't have a definite state until something, a detector, an eye, a camera, you, interacts with it. So is the moon there when you're not looking? Technically, yes, because the air, the photons from the sun, the dust in space are all constantly observing it. Big objects can't escape measurement. But the underlying reality, the actual stuff making up the moon, the quantum guts of every atom inside it, that stuff only becomes definite the instant something checks. You are, right now, in this very moment, helping to render the universe. Every photon hitting your eyes from your screen has just collapsed from a fuzzy possibility into a sharp, definite reality. You're not separate from physics. You're part of the wiring. And honestly, mate, I reckon that's the most beautiful thing science has ever discovered. If your brain is buzzing right now, do me a small favour. Drop a like, hit subscribe so you don't miss the next one, and tell me in the comments which of these 8 experiments blew your mind the most. I read every single comment. Next video, we're going deeper. We're breaking down Schrodinger's cat properly. No nonsense, no cliches, the way Feynman would have wanted. Until then, stay curious. This is Curious Physics AU. Cheers.